Hello, everyone, and welcome to today's Tech Sessions podcast. I'm your guest host, Jeff Dickman, filling in for Kevin Cohn today. Today, I'm with Roy Douber, who is our Senior Director of DevOps and Architecture at E360. We are going to be talking today about SQL migrations and opportunities for improvement with customers around cost efficiencies or technical upgrades, things like that we can cover with that. And so, Roy, did you want to briefly introduce yourself and give a little bit of experience that you have within the cloud environment?
Yeah, so my name is Roy Douber. I've been here at E360 roughly 2.5 years at this point. We've worked on projects in the data space, in the DevOps space, in the cloud space. This particular episode is around SQL. However, we tackle a lot of problems, and that's kind of what I pride myself throughout my career, solving difficult problems. And I have a past as a site reliability engineer lead as well. Pleasure to be here.
So, Roy, in this discussion that we're going to have today, we're going to be talking about taking an environment, running a large amount of smaller servers, and how we are a large amount of servers and how we scale that down for a customer to provide improved performance. Is that correct?
Yeah,
Yeah, cool.
absolutely.
All right. So let's get started then. Can you describe the initial challenges that we had with the customer and how we started to address those?
Yeah, so the client came to us with a particular challenge. First of all, they had a large footprint that was very difficult to manage. And they were struggling to just keep the lights on. The environment was going in and out of sync. They were having a lot of operational toil within the environment, and they were looking at avenues to reduce that. And so the first thing we did was really look at their, not just their billing, but look at the estate and look at how they service their customers and index that, including the financial picture of what this looks like. Obviously, whatever re-architecture needs to be done for operational toil or not, it needs to be financially sound. And we started with kind of the financial picture of the existing current state. And then we did the full current state analysis. We made sure we understood exactly how the customer, the client, serves all of their clients. This is one of the largest estates in the world for SQL in this specific sector. And we analyzed everything. We came up with a picture of what it looks like. We represented that to the customer. The customer agreed, yes, this is what it looks like. This is how much we pay for licensing. This is how much we pay for Windows licensing. This is how much we pay for the boxes that are custom sized to fit our clientele on. And so from there, we gave them multiple options of potential architectures. Before we even began any engineering, we were like, okay, well, here's some things we could do, right? And then we continuously chiseled down at kind of the top 3 solutions. And then we went deeper. And the idea was to address those operational inefficiencies, to address the high costs, ideally to take the number of servers down and service more customers within a cluster, right? Which was important for them because they had some noisy client issues with the smaller servers, meaning one customer would go online potentially, and oftentimes they'd have to move customers around to kind of fit into their SaaS better because certain clients were just too big to be good neighbors within the multi-tenant environment.
Okay, so it sounds like they were playing Tetris quite a bit with their servers.
Yeah.
Would you say that the issues that this client was experiencing were that they're pretty common with customers that are running SQL in the cloud?
I think so, especially in a large multi-tenant environment where you're trying to optimize the database for each client, and any rise in costs is directly offset to the client, right? So you don't want to raise your costs on the client continuously. So you're very sensitive to any of those types of changes. I would say it's very, very common to run into some of these noisy neighbor type situations and moving clients around. And what we've seen is that oftentimes the best way to address that is to have a larger moat, essentially. So if you have a larger server, then it mutes some of the spikes in usage. So a large client comes online, does some batch processing job that they require for the SaaS, that's what they're trying to do within the platform. That's okay if you have a larger server that can handle that spike in traffic.
Okay.
So it creates a scenario where they can fit 3 times the clientele on a larger server, but yet the cost is not 3 times. So
Does that mitigate the noisy neighbors though, when you
Yeah.
put them on a bigger server?
yeah, because you have more capacity to handle the traffic. So you're kind of muting the response. So whereas initially you'd be serving, let's say, 100 clients, you could serve 300 clients, and not all those clients come online at the exact same time. And so your peaks are lower because you have more resourcing to handle the load.
Okay, cool.
Yeah.
So as you worked through this, can you kind of give us an overview of the solution that you implemented with this particular customer?
Yes. So the customer had a very specific use case in that they required in-memory databases. And so for this client, they were having a lot of pain with always-on availability groups. And so we defaulted on a secondary option, which is failover clustering, which in its nature also allows you to have one less instance online at any given time. So with an always-on availability group, you have to have 3 instances online as a minimum. And I believe in some cases you'd want to have even more than that, because it just, again, it allows you to have more flexibility. And it's also, there's some licensing magic where you benefit if you have more instances online, but they were running into a lot of desynchronization issues. And so failover clustering it's much easier to manage, and I feel like fits a bit more cleanly into the cloud than always-on availability groups. You end up using just a different set of configurations, and for this specific client, this was the right move. There's certainly situations where always-on availability makes sense. In this specific case, failover clustering makes the most sense, not only from a cost perspective, but from a data, disaster recovery scenarios and other scenarios. It just made a lot more sense. And the idea is as well, so when you're using failover clustering, let's say you have those 100 clients that sit on one instance, it's an active configuration. So if one instance does fail, the 100 clients fail over directly into the secondary instance. So you're still online, there's still high availability. There's still DR solutions that can facilitate a regional outage. And it still allows you to have kind of that, the benefit of using a larger server and not having to run kind of an N+2 style configuration for your SQL environments.
Okay, cool. So we're talking about 1/3 less servers here. Like, from a quantity standpoint, what does that really look like?
So the depending on with this specific solution, there was a ratio requirement around CPU to memory that fits the profile of the usage of the client best. And so if you can find a high enough memory server and a low enough core count, that is beneficial for the clients and the workload, because Windows gets licensed by the core, I believe, and SQL gets licensed by the core. And so you're paying by the core, but if you can allow for more memory throughput, great, right? Like your clients will have a much better customer experience. And so that was
Okay.
the premise of the
So
project.
when
Yeah.
you're looking at this, when you're looking at this setup, right? It sounds like it was a lot of servers. Did you have to like set up SQL on all of them, or did you have an automated process for deploying SQL?
Oh, so everything is automated, and terraformed out and thought through down to the nitty-gritty optimized configuration for IO and how we optimize down to the very nitty-gritty, because these are production clusters serving clients that need the data as quickly as possible. So
Okay, cool. When we're talking about SQL, right? Storage is important, and high performance with the storage is really important. What kind of things did you implement around storage to ensure that the SQL servers would see the necessary IOPS for their
yeah,
workload?
so we did a full analysis on various storage technologies that are available to us, and even we're looking at some preview or future forward-looking storage capabilities, and landed on a multi-rider style configuration that allows for the highest level of performance per cost for the client and still allows for the level of IOPS required, so that it meets and exceeds the current configuration by a significant margin. So when we ran our testing, not only did we run into certain configuration flags and certain optimizations that we made along the way for the client that improved the overall SQL posture. So everything was running faster. Their startup times were faster. We found one particular trace flag that we were able to enable that sped up. I don't remember if it was restore time or the startup time by like 10 times when you recover an instance. So we were very thorough with our analysis of the internal environment, and that led to some serious savings post the extensive testing and validations that we ran for the client. Even with their current environment, they were able to implement some of the trace flags and changes and optimizations that we made in testing for the new environment. So a huge testament of success building out this and just looking at an older environment that just needed some love and caring.
Okay. So it sounds like when you're doing this kind of an activity where you're going to be, upgrading your databases, changing your architecture, potentially even moving between clouds, one of the things that you want to have is a really solid testing plan to validate performance and take care of those things. Would you say that you need to have a similar approach for the financial analysis of the project?
Oh yeah. So it starts. I think everything starts with finance, because at the end of the day, as a large company with a large SQL estate, you want to be able to go to your board and say, "Hey, if I make this big investment to make this change, it has to be worth it in dollars and cents." So that's a part of it, and not only from a cost, so your cost is one piece, but then also exercising the system in production under various settings, under various load scenarios with load testing, and really ensuring that the end result is going to be something that the team that manages this can support, first of all. that the operational toil is far, far lower. Because, so financial is one piece, but there's also soft costs. If my DBA team is working 12 hours a day, just trying to keep the lights on, then I'm not moving my customer storyline forward. So there is no incremental improvements that I can make to the underlying system or systems for my clients, so that the system continues to improve from a performance, from a value perspective across the board. And
Yeah.
that was very much the case, but that never shows up in the financial reporting, right? That's often termed soft cost, but we think that your engineer sleeping at night is equally important to the financial savings. You want to retain the engineers, you want to keep them around, you want the engineers to work not just on operationally toiling tasks. You want them to be able to go and tinker with the system and improve performance and look at ways they can create additional value for the client.
Yeah, for sure. Well-rested engineers definitely get more done. So
yeah.
So when we're talking about the cost savings, that we did an analysis and we came up with what those cost savings were going to be. Sometimes when we do that and we actually implement the solution, the cost savings aren't always what we projected. But in this case, I think we exceeded expectations a bit. Can you talk about how much we saved this customer through the course of this project?
Yeah, so this is over 5 years, this was in the tens of millions of dollars. So this is awesome. This is an awesome exercise. So we mapped out all of their resource costing over time. We had a chart that showed basically a graphic that showed what would happen if they continue going down this path. What if they were to do a 12-month migration, and there were two different configurations. One was actually looking at using some kind of a data pop structure where they almost take things back on premise, which is something that they also considered. But it ended up that the benefits of cloud and years invested in the cloud and terraforming and all the value that cloud provides, while it may not appear again, when you just look at a machine that you're spinning up anywhere in the world, I guess, the cloud is very beneficial.
Yeah.
And having the flexibility of the cloud and being able to spin up SQL instances on demand for this client was very, very important, especially as their product is growing all the time.
Okay.
So that was the decision we went with, and I think the end forecast was roughly $30 million over 5 years.
Wow, that's pretty phenomenal.
Yeah.
So you talked a little bit about like the soft improvements, not just the engineer sleeping, but less time spent on what I like to call the tyranny of the urgent, those outages or those issues, or playing Tetris with the data to make it all perform. Were there other operational improvements that the client experienced post-migration?
So the client had a DR strategy. I don't know. It felt like they didn't exercise it enough for it to be a proper DR strategy. So we've revamped that as well as a part of this. Obviously, we mentioned before there's faster recovery times, more optimized resource usage. So really, the noisy neighbor issue that we discussed should happen far, far less if you have a larger server to kind of blunt the load across various clients. And then from an administrative overhead, right, like we mentioned, I mean, I got a chance to look at the client's PagerDuty alerts and how often the DBA team was being paged, and it was basically, if you took the number of DBAs and the number of hours, it was more than a working week of paging and escalation. So no chance to improve and always operating with their hair on fire. And ideally, with this new configuration, a lot of that should go away. We'd expect it's a much simpler configuration, and therefore, keeping it simple, I think, is very valuable in this scenario, especially with a large estate, and they're going to reap the benefits. We believe that once this is fully rolled out, they're going to experience less than half the amount of toil they currently experience. So
Okay, cool. So you also mentioned just a little bit ago that there's a lot of benefits to using Google for this and within GCP taking advantage of services that are there. Did you use GCP's on-demand scaling for this project? And if so, how did it benefit things?
yeah, so some on-demand scaling, definitely more on the storage side, some of the latest and greatest services like GCPDR for backup and recovery, some of their latest SSD, PDSSDs that are configurable for IOPS were leveraged, and we implemented high availability and data integrity. And we were looking at kind of what is the best possible scenario for the client from a failover perspective, from a startup perspective. There are various configurations that we were looking at any given point, and kind of from a GCP perspective, we were able to leverage some technology and some we were not. So, for example, because it's in-memory databases, we could not use Cloud SQL, but we could use GCE, and we could and that works just as well. There's also a dependency on Windows, so Cloud SQL currently runs on Linux, so that kind of impacted the decision making that we had to make along the way. So that was also looked at as a potential option, but it was just not chosen. And the multi-writer technology is an kind of a really new feature in preview right now, I believe. And we were leveraging that, and we were also using some under the hood Windows technology that was required because of the choices that were made along the way. This is also a relatively old application, right? So there's certain constraints that you have, and I mean, anybody that's running a SaaS application at scale had to make some choices along the way, and sometimes you have to stick to those choices. You don't have the option of refactoring the code today or in the next couple of years even. And so you stick with the choices and optimize against those choices. And that's exactly what we did.
Yeah, when you talk about that, right? The idea that you had these guardrails or these boundaries that were around, sort of what you could do with the application. You couldn't use Cloud SQL because you needed, capabilities that only exist in SQL for Windows, and it had to be in memory. And so, you have all those pieces, and yet you were able to still achieve a forecasted 30 million savings over 5 years with that. Is from a financial standpoint pretty awesome, right? How do you compare that to the pieces of this that would make it technically awesome? Like, what was, in your opinion, the most innovative thing that you did within this SQL solution that you built?
So I think just simplifying, right? I really think that the original state things were kind of the bespoke best practice, but the reality is that sometimes simple is better. So technically awesome, the users were experiencing issues, the customer experience wasn't great, the there were a lot of outages, unplanned outages for the clients, and by keeping things simple, we're working towards alleviating all of that and creating a more awesome environment for the clients. And I think that's the most important thing. If the client senses that every time they log into the system, it's clunky or slow, then over time you've lost the confidence of the client. And so I think that's what we achieved. We went from an architecture that on paper should be the best possible architecture, but realistically was not in this specific use case. And we architected to something that will be simple to maintain, grow into, and continue leveraging the future roadmap in GCP to continuously reduce costs over time. But there's some future roadmap coming to GCP that's going to reduce the cost of this technology even further.
Wow, very cool.
Yeah.
So you mentioned that you did automation around this, right? That there's definitely automation in play in this. How did you enhance the deployment process for the solution using automation? Like, what did you automate and what tools did you use to do that automation?
Yeah, so again, the application relatively old. They were using desired state configuration, which is a PowerShell kind of add-on to manage it, which is still very widely used. It's not a bad tool necessarily. It's just less cloud native. And so the move that we made here is moving to everything towards more Ansible. So Terraform, Ansible were tool choices that we made. We're also leveraging Nomad for some of the server builds, so images. And it'll be a much more cloud native, cloud friendly automation process moving forward. In some cases, because there's a timeline, right, and we're trying to save money, we had to wrap some of the automation scripts with Ansible, with the idea that in the future we're going to refactor. But we tried to take as much of this as a first principles approach. So we removed what we felt was not needed and just did the most basic spin up so we could get up and running and online and achieve the financial cost savings that we're shooting for. So
Okay.
yeah,
It sounds like
the longer we take. Go ahead.
Yeah, it sounds like as you did this, you sort of planned for the future, and you've ensured that there's going to be some scalability and some flexibility for the customer in the future as new services are released in Google and as maybe they evolve their application. Can you talk a little bit more about that?
Yeah, so the customer is going through a bit of a renaissance, right? As I think many other companies are going through. There's a big platform engineering push. So they're hiring SREs and platform engineers, and they're building internal resources as a service internally, which was just not the case up until this point. And we were trying to fit the solution for all those goals the customer was pushing towards. So working with the client to understand exactly what they've got in their ecosystem, not just from a SQL perspective, but holistically, right? We're going down the backstage route. We're going down the, we want to use Ansible. We want to use Terraform. We want to use Terraform Cloud. How do we build this in such a way that it's maintainable, but it's also not so bespoke, so that a new engineer can come in from another company that has kind of these relatively prevalent technologies and come and get to work, which was not the case before. So again, simplifying, using kind of established processes, established practices in the cloud, using established tooling in the cloud, bringing things to a point where it's no longer a question of how you deploy this this application, which, again, we've improved their build up startup time by 6 to 10 times over through this process. It's we're completely, we were always thinking about the future engineers, those engineers that are new, the junior engineer coming in from another company or from school. What tools would they like to use? How could they, without having to train them on kind of technologies that were going out of favor, or
Yeah.
even looking at some of these older scripts that existed in the environment that nobody even understood what they do anymore, because there's been, either churn or people have just moved on from those scripts, but they're still being used in a production setting. Why was this flag enabled? Why was this particular piece installed here? Nobody knew. So first principle approach. I'm a big fan of deleting. As long as things continue to work, delete, and until it breaks. That's essentially what was done here. I mean, we didn't, oftentimes we didn't even look at the old code, and we just planned ahead, had a conversation of what was required rather than what was not required, and
Sure.
pushed forward. Yeah.
Yeah. So it sounds like as you went through this project, that was some of the things that you had to figure out was like what worked, what didn't work, what was just old legacy kind of like Klingons in the code that you had to deal with in order to get things working. And some of that I'm sure helped improve performance as well as you were doing startup and failover and things like that, because those things didn't have to be executed anymore as they were removed. So one of the things that I love about projects is that there's always a learning curve, and there's always ways that we can evaluate these projects to do better, in the project and next time for the next project. So within this project, were there any unique insights that you gained around the project, and how the project went, and things that you thought were valuable that you would recommend to other folks as they're looking to maybe do similar projects around Microsoft SQL and implementing it on Google?
Yeah. So I think keep things simple, right? Run through, create a very thorough testing and validation plan. Leverage cloud native solutions as much as possible, right? But as long as they fit into the end solution that you're trying to implement, right? You can't always get what you want, right? Unfortunately, so in some cases you have some constraints that you have to work with, and then choose the right solutions, the storage solutions, configurations that fit the workload, right? I think oftentimes as engineers, as architects, we always like the cool shiny things. Sometimes the cool and shiny things is not the right answer for an enterprise large environment. Sometimes it might be the dollar the path more well traveled, that might not be as common or as commonly recommended, or the newest shiny solution that came out of the labs in the last couple of years. It might be the more tried and true.
Yeah, as a geek, it's hard for me to agree with that, but it's absolutely true that the tried and true tooling and capabilities are sometimes the right choice, while you wait for the newer stuff to sort of mature and get rounded out, and so the rough edges are a little bit more gone. But sometimes it can be painful because implementing the cool stuff is always really fun.
Yeah, and there's small skunkworks projects that really fit for some of those new cutting edge technologies or bleeding edge technologies.
Yeah,
you start there, and
sure.
eventually maybe they end up a large estate that does all the magic, but generally speaking, it's not it's not, those would not be an overnight success, right? Like there's bugs that need to be worked out. There's configurations that are not well documented. And so in this specific case, I think with the old configuration, the client kind of bit off a bit more than they could chew. And I'm glad that together we were able to come to a decision that was more reasonable from a toil perspective. Not from a toil, from a cost, from a value to the client perspective.
Yeah. So no project goes on without issues or problems. Were there any lessons learned that you had on this project? Things that were like totally unexpected, but you know, if you ever do it again, you're gonna think about?
You know, we again, we started with many solutions, some on the bleeding edge, some on the cutting edge. I think we ran into issue. We vetted technologies that just did not work, right? Like we believed that they would work, and when it came down to exercising the solution, we realized that the in-memory databases became a constraint on the storage solutions that we picked, right? So we had to scrap them. So I think there is a lot of lessons to be learned through any project. There's a lot of failures, and your best bet is to have multiple configurations that you're going to vet, and eventually land on one that works, or at least one, maybe a couple, and then pick from the couple. So we never came in with the notion that everything we were going to propose were going to work. I mean, this is a unique problem for a unique client with unique specifications. You build and you discover as you go. It's not if it were easy, the client wouldn't have requested any assistance whatsoever, and the very smart engineers the client have would have resolved this issue a long time ago. But they came to us because we had some know-how, and we've had some expertise with these problems, and they could lever, and together, putting our brains together to solve that problem was ultimately way more beneficial for all of us.
Yeah.
Everybody.
Yeah. Do you have any pro tips for architects or engineers that might be taking on a project like this?
Yeah. So if it's at this scale, when you're talking a massive estate, cost benefit analysis before any migration, test, automate as much as you can. You don't want to be doing anything manual. And I don't believe, humans are good at many things, but we're very prone to errors. So automate all the time. Any sub process or any subsystem that you can should be automated. And then be adaptable, right? Regularly review and optimize configurations and adapt to any changing requirements or any changing roadmaps from the hypervisors that you're working in, because ultimately that adds the most value for your customers or for your company.
Yeah, okay, cool. Yeah, those are great pro tips. So the migration that we went through with this customer was taking their legacy SQL environment and optimizing it with failover cluster, implementing automation for SQL. We did a huge amount of financial analysis on this to make sure that we're implementing the right solution. And then in addition to that, the technical analysis to make sure that the right technology was being put into place, as well as the test plan that was done for that was all pretty heavy from a lifting standpoint and from a workload standpoint. How many, just rough estimate, how long did this project run to get from the point where we started having conversations to the point that we actually implemented with the customer?
I think we're coming up. It's still ongoing, obviously, but I think it's coming up on roughly a little bit less than a year, 10 months or so. So
Okay.
this is very, very thorough. nothing like this can be done in a vacuum or quickly.
Yeah.
It
So it
depends.
sounds like a lot of due diligence went into this, and I imagine we spent a lot of time, collaborating with the customer and presenting to their executive leadership on the plan and potentially what they were going to see from a performance and a cost standpoint, so that the business impacts would be fully understood there as well. Hey, Roy, I got a question for you. So E360 does a lot with cloud. Where can potential customers or anyone interested go to find out more about what E360 does or get a demo of the capabilities that we offer?
Obviously, E360.com has a thorough list of services we can offer, from DevOps to cloud architecture to bespoke software engineering. Whatever your needs are, we generally have an answer. And if we don't, then that's okay too. We'll find somebody that we could forward you to. But we could do a lot, and we encourage you guys to explore everything that we have to offer, including, our SQL migration or cloud migration engineering teams are fantastic, and we've done quite a few of these now. This being one of the larger ones, and also we now have tech sessions on YouTube and a LinkedIn. I believe it's E360 Pulse. You can see where we have some tech news that we release, and you can also follow this podcast for more insights and updates on the latest and greatest in technology, or in this case, maybe the kind of tried and true technology that you may want to use in your day-to-day.
Awesome. Hey, Roy, thanks for your time today. I appreciate you walking through this project and the things that were done on it and how we helped improve efficiency and cost for our customer. I think it's been really fantastic. And to our listeners, thank you for hanging in there and listening with us as we covered all of this. This has been another Tech Sessions podcast from E360, and I hope you have a great day.
Thank you.